morning from Lympne Airfield in southeastern England in 1944. This is Firefly. I'm flying with the VMF 214, the Blacksheep, under Squadron leader Serpent. Today I'm tasked with showing you how to plan a mission, a flight under World War II conditions with the Dead Reckoning method. And yeah, as you can see on the map, our flight will start at Lympne Airfield. Our first waypoint will be this town over here where the railway is coming from the north. It's Paddock Wood, I believe. It's called Paddock Wood, and from there we will continue almost straight north to our beloved airfield of Gravesend, where our flight will terminate. Yeah, I would like to walk you through the steps of planning this mission, and then afterwards fly the mission and see if the numbers check out. When I go on such a flight, I like to prepare a flight table. Like this, where you can see all the checkpoints: Lympne Airfield, where we take off from, Paddock Wood, here, and then to the north, Gravesend. I plan to take off at the server time of 9:30. Let's see if we can make this. And for each flight leg from here, for example, Lympne to Paddock, I have a row of values which I try to observe. For example, we can see here the first flight leg is 25 nautical miles long on a course of 281 degrees, and then we have all these other things which I'm going to talk about. And then for the second flight leg, we turn to starboard to 358 degrees, which is our course to the north for 14 miles at 6,000 feet again altitude. And yeah, our task now in planning is to find out how long each flight leg will take us, how many minutes at a given speed, and yeah, at which heading we actually have to fly, because the course here from A to B on the map is sadly not what we set up on the compass, because of the wind, for example, and because of the magnetic field of the Earth. So we have to calculate this if we want to do it as precise as possible. So if you want to follow me on this journey, then I invite you to do so. So let's take the first flight leg. We have our course at 281 degrees. This is this straight line. When you plot this course on the DCS map, you can see this true course here. I think the British, they call it the track. This is the straight line. One thing to observe is you can see already there's another course here, 291 degrees M, and M stands for magnetic. This is because the magnetic field is not oriented in the same direction as the true course to the geographic North Pole. You can also see this on this compass rose, which is on every DCS map. With the star here, you can see the course to true north, to the geographic North Pole. It's this direction here. And at this place in time, in 1944, and in this place here in southern England, you can see the compass needle actually is not pointing to the true north, but it was pointing here to 351 degrees, so a bit to the left. So whenever I plot a course on the map like this, 281 degrees, I have to add 9 degrees to get the I have to add the 9 degrees, yeah, to see what my compass would show. So this is then the magnetic course, you could call it in this case. So this we have to observe, and this you can already see it here in the second to last column. The magnetic heading is where we put this number in the end. So this is one thing we have to observe. When I fly, I have the airspeed indicator in the cockpit, and I want to fly at an indicated airspeed of 200 miles per hour. And now when I start my calculations, I have to observe, for example, that I have to convert the miles per hour, the statute miles, to knots, the sea miles, the nautical miles per hour. So I have to make this conversion to get, as a first step, to get to my true airspeed. The true airspeed is the speed at which the airplane is flying through the air. And this is also depends on the altitude. And yeah, I'm going to show you the steps to get there. The next thing is the wind, because when we are flying, the wind can come from the left, starboards, from the left or from the right, from behind or from the front, and all this affects our speed, of course, and also the heading. Do I have to compensate for this wind drift? So there is a wind correction angle, which we have to calculate and then observe. So, but what is the wind? At the moment on our server, we have certain weather conditions set up, and you can always check the briefing for every DCS mission, and there you have some weather information, and this is a little bit small here, but you can check this in your own game. And for our mission today, the wind is coming from 101 degrees at 6 meters per second, which is roughly 12 knots. You can see this here at 8,000 meters. This is which would be times 3 at 24,000 at 6,000. It's the wind is at 122 degrees actually, and we are flying at 6,000 feet, so I have to correct this already. 122 degrees, and the wind speed is 7 meters per second, and that would be about 14 knots. So this is important for our flight today. So this is the weather, the wind conditions. I also like to include a table in my flight plan, so I can delete a table in my flight plan for the climbing. Today we're not climbing too high, so it doesn't affect our planning too much, but if you climb to very high altitudes, keep in mind that this takes some time. So for example, 25,000 feet, it takes 20 minutes in the P-47, after which you have flown 50 nautical miles over the ground, and you spend 50 gallons of fuel. So but today I'm just neglecting this. So back to our flight plan. How did the pilots do that in World War II? They didn't have GPS and all the nifty electronic tools which modern airplanes have. So let's have a look at this, and I like to plan my flight with similar tools, just to mimic a little bit these conditions. I like the role-playing part of flight simming next to this organized style of flying. So of course the pilots had maps, they had some kind of protractor for their missions, And what else? After they took all their angles, headings, bearings, and distances from the map, they used analog, kind of circular slide rules, which were called and still are called flight computers. And still today, pilots are learning how to fly using, of course, more modern versions of this in analog. I have one which I use in DCS here, but of course you have all kinds of online tools as well that can be used. And yeah, in World War II these looked like this. This is a German one, this is a Japanese one, I believe, and this is a British flight computer. If you want to buy one or look this up on the internet, look for E6B, search for E6B flight computer, or I personally like the CRP5 flight computer. And all the web pages I'm using today showing you are on these URLs. Just check them out as well if you like. So, and after having filled out this table which I showed you before with all the numbers having been calculated on these nifty tools here, you get to climb into the cockpit, and there you use certain instruments during the flight. Mostly the clock, because you will have the information to have to fly for 7 minutes in this direction, and then another 13 minutes in another direction, and then you can see this on the clock here. And of course you can write the actual times in the table, in your flight planning table. Then of course you have the airspeed indicator here. We are setting up our flight for 200 miles per hour, so I am trying to observe always that the needle is here. We are flying at an altitude of 6,000 feet, so about here, so more or less. Doesn't need to be super exact, but somewhere there. And then of course we have our main compass, where we set up our heading, and since this tends to move left and right and all the time, you can also use the gyroscopic compass as well, which can be calibrated according to this compass here. When it stays more or less stable for a couple of minutes, you can calibrate your gyro compass here, and you have to repeat this every so often, because this also gets messed up over time, and that's what the pilots did in World War II. So this is just the basic introduction, and now let's fill out our table. So we take the information from the map, the distances, and the course direction. As I showed you before, you can get this from the DCS map, and put the numbers in here. You have to know the altitude. Also the temperature can be of importance, but if it is around between 0, 20 or up to 40 degrees Celsius, I wouldn't worry too much about it, and I don't use this in calculations. But if you have extreme temperatures, especially down below 0, it can alter your true airspeed. But usually I don't care about it too much. So we're starting our calculations at our indicated airspeeds, and the first step we have to take is convert the miles per hours to knots. So let's switch to our E6B flight computer, and you can see this here. If you match the two 10s here, then it is kind of zeroed in, or at a basic state here. You have an inner circle, these numbers here, and the outer circle. And you can already see here you have certain units written on the outside circle, and the one we're interested in now are the statute miles in the upper left corner here, and the nautical miles. And yeah, we are flying at an indicated airspeed of 200 knots, so I put this here at this statute sign here, and then I read the circle from where the arrow is here. So 174 knots corresponds to 200 miles per hour. So this I put in the table. But this is not the actual true airspeed, it's just the conversion of miles per hour to knots. The true airspeed you get when you see how much this changes, because this is only the true airspeed at ground level, at 0 feet above sea level, and at 6,000 feet you are a bit faster because the air is thinner. So we also have to observe this and set this up, and this you do in one of these windows. Here the airplane is at sea level, 0 feet, and you can see that here at 0 feet the temperature, which is here on this outer scale, is on all these flight computers set up as 15 degrees Celsius at 0 feet altitude. So we are today flying at 14 degrees Celsius, so this is almost exactly like these standard conditions, so we are not worrying about the temperature. Now we move the scale here to our 6,000 feet altitude, and what we can do now is convert our 174 knots here on the inner scale to 190 knots true airspeed at this altitude and temperature. 190 knots is our true airspeed. So this is how they did it and how you do it with the E6B flight computer analog. Of course, today we have also online tools, and one of them is shown here. I already showed you the URL. So we want to get our true airspeed. First of all, the temperature at sea level, 15 degrees, is the standard temperature. Today we are flying at 14, and at 6,000 feet, we have 2 degrees Celsius. So if you want to find this out, you can do this with this Omni calculator here. Yeah, on this page, on this website, you can also convert your true airspeed, your indicated airspeed to true airspeed. You put in your altitude, you put in the outside air temperature, your indicated airspeed in knots, which was 174, and then you get, of course, the 190 degrees, which we already put in here. So now we use the true airspeed to get our wind correction, and this is set up on the flip side of the flight computer disk. Go to the flip side. So I set up everything wrong. So it's of course 122 degrees. This is where the wind direction comes from, at the direction where the wind is coming from, and then again 190, and it's 14 knots. And now we put in our heading of 281, and now we can see, now we put the dot again on our airspeed 180, and we can see that we are now faster, not 14 knots but 13 knots, and we have to compensate by steering the airplane 2 degrees to the left. So it was 13, so it's only 203 knots ground speed. Wind correction angle is -2 degrees L to the left. So our heading is not 281 degrees but -2, it's 279 degrees. Yeah, and this is what the website also shows us. -2 degrees wind correction, 279 degrees, and the ground speed 203 knots. So, and now if we want to calculate how long this takes us, you can use the E6B. We set up this triangle mark here at our ground speed 203. This is 2468, so this is 203 knots, and our distance is 25 miles. So on the outer scale we find the 25, and here it's between 7 minutes and 8 minutes, so I would say it's 7 minutes and let's say 20. So you have to how to say this, with these flight computers you should not take these numbers just as for their literal values. You have to think about it, because here it says 70 and 80, but at a speed of around 200 knots for 25 miles you don't need 70 minutes. So sometimes it's times 10, sometimes it's divided by 10, so use your common sense to make sense of these numbers. So 25 minutes, 25 nautical miles, 7 minutes and 20. Now let's see if this checks out with the website as well. 25 miles, 7 minutes 23. Yeah, good enough for government work, right? So in this we repeat now for the second flight leg. 358 degrees. Again, our true airspeed is of course 190 degrees. We are flying at the same altitude, and our indicated airspeed is the same, so we start at 190 degrees. 358 degrees wind from 122, of course, 14 knots. This with these new numbers. Yeah, so go to the flip side. So again, the wind is coming from 122 degrees. The wind is 14 knots. We have a new course. 358, almost due north. Now the wind is coming from the right and it's still pushing us a bit, so we will be faster, but we have to compensate by steering to the right this time. And by how much? Speed is 195.6, let's say 7, 197 knots, and I would say -4 degrees is our correction. 197 -4. But it's of course to the right, it's plus. And 197. so I'm not as fast anymore over ground. +4 would be 194. Oh no, wrong column. +4, 002 degrees. Let's double check with the website. Now our course is 358. True airspeed again 190. Wind stays the same. Correction angle +4. Heading is 2 degrees and ground speed is 197 degrees. Distance was 14 nautical miles. At this ground speed it's 4 minutes and 16. Let's see what our result would be with the E6B. 197 knots ground speed, distance 14. Yeah, so 40. This is 4.5 minutes. So 30. Yeah, 4 minutes 20 would have been my guess here. Let's say 420. World War II conditions, right? Without internet. So almost ready for the flight. So the true heading after wind correction, that everything is 279 for the first leg, but we have to keep in mind the magnetic variation. So this is the true heading. We have to add 9 degrees to this. This right magnetic variation was to the west. West is best, so we have to add, yeah. So +9, 288 degrees would be our heading for the first flight leg for the compass, and for the second it's 11 degrees. So now fuel considerations. I always calculate my P47 at 100 gallons fuel consumption per hour. So what is 7 minutes? So that's 1.7 gallons per minute about, times, let's say 8 minutes. So it's 14 gallons, but on the safe side here. And then, yeah, for half the time, 7 gallons. So we're not spending more than 21 gallons. That's the fuel consumption. If we want to take a reserve of 100 gallons, so it would be 120 gallons of fuel. So let's set up our airplane with 120 gallons. So this is almost it, but for safe flight I want to look at the airports as well. I have never taken off from Lympne, so it's supposed to be in a direction, so the runway is supposed to be in a direction of 70 degrees. So we're starting from one of these ramps here and then take off in this direction. That's just a grass field. Okay, Paddock Wood is, yeah, this town here. We are looking for this straight railway line, which we converge to or with, and then this peculiar railway line is taking off from Paddock Wood. Also we have these lakes here, and we have to look out for these objects. And Gravesend is our home airfield for the Blacksheep in England, so I'm quite familiar with this one. We have the large hangar here. The runway is just due from north to south at 180 degrees, and we will land from the north to the south. So now the very last thing, The objectives are just to navigate to Gravesend through Paddock Wood, 6,000 feet altitude. That's our orders of the day, I guess. And then the rules, even if we see enemy, we are not to engage, but if they attack, of course, we can fight back. We are still in flight training, so we have to remember the basics, not to get caught up too much in the navigation stuff and forget about everything. And yeah, stay safe. Okay, see you in the cockpit for actually flying this thing. Bye bye. Okay, here we are in the cockpit. The flames on the horizon are my first takeoff attempt. I ran into a fence on takeoff. Yeah, so we try this again. It is 10:40. I'm going to reschedule the flight to 10:50. And as you can see on the screen, when we take our first flight leg is about 7 minutes. So we should reach Paddock Wood at 10:57, and then another 4 minutes, 5 minutes. We should arrive at Gravesend at 11:02 if everything goes well this time. Lympne Air Traffic Control. This is Firefly requesting permission to taxi to takeoff position. Over. Okay, let's assume that permission is granted. Then let's unlock the tail wheel and slowly taxi to the runway. If it's really called a runway, if it's a grass field. So altitude is set to 200 feet. We are putting down flaps a little bit. Trim to takeoff position, a little bit nose up. Oil cooler shutters opened. We're not getting too fast here, hopefully. Okay, now I'm a bit nervous concerning the takeoff. Everything looked clear in this direction, but there is a fence on the other side. Ah, these are the markings for the runway here. Let's see. According to our airfield diagram / screenshot, takeoff position was takeoff. Heading of the runway was 70 degrees. Now at 30 degrees. Now the heading here is 30. Yeah, let's try it this time. In this direction. Let's close the cowl flaps a bit.
Chevy 2-1, request takeoff.
Okay, takeoff permission, but I want
Chevy
to take
2-1, request takeoff.
to take less fuel than that we planned with. 120 gallons, so 34%.
Request refueling.
Station should be good.
Copy.
Lights, guns unarmed but gun sight on, seat position, and fuel.
Refueling complete.
Okay, looks more like 130. 140 gallons, but that's good. So I guess we take off and then circle the airfield until 10:50. And then initial heading will be 288 degrees for 7 minutes 20.
Rearming complete.
Okay. Tail wheel locked, of course. Full pressure now. Okay, somewhat better now. Flaps up. Pressure back. Already put it in power setting for my flight. I like to fly at 30 inches of pressure and somewhat of 20. RPM. So fuel consumption will be quite low. Speed indicated is 150 miles. Already lost eyes. Airfield, where is it? There. Okay, 3 minutes till we embark first flight leg. Trimming is good on this. Let's close the call for a minute. 30 seconds. So I'm trying not to look at the map because it will show me my position. And I didn't want to fly just by Dead Reckoning. So halfway on our flight, our first flight leg, there should be an airfield below us. So at 3 minutes 50 something, so at 10:54, 10:55. We should see it. So now we're good on our heading. I want to go a little bit more left to compensate for our being too much to the right at the beginning. And always to do my rudder trim. Keep the ball in the middle here, aileron trim, elevator trim for a gentle climb, and also watching my indicated airspeed at 200 miles per hour. We are approaching 5,000 feet, so not going too much higher. See the airfield anytime now. Speed is good. Heading is okay. Going to go back now. Where's this airfield? Railway line. This looks like it. Converging. Is this a railway line? And Paddock wood. Heading 270 is too much to left. Calibrate the compass. There are the 3 lakes, and just east of these lakes there should be a Paddock. Okay, I'm not too fast. About 5,000 feet. So this is Paddock Road, right? This is a railway line. This characteristic turn, there it is. There's the turn of the railway converging with the other one. So this is our waypoint. And at about the right time. 10:57, 30 seconds. So this is good. Now we're turning onto our new heading. Of 2 degrees for another 4.5 minutes. Ready there? Let's do a quick check. 107, so a bit more to the left. Fast here for our flight plan. Heading 101. Correction of 9 degrees magnetic. Our heading is supposed to be 11 degrees. So again, not very good on the heading. Second flight leg. 11 degrees. 5,000 feet, not 6,000 feet, but that doesn't affect us too much, makes us a bit slower. I believe we can already see Gravesend directly in front of us. If I'm not mistaken. We will see. So it's 11:01. Calculated flight time is 11 minutes 40 seconds. My stopwatch is been 11 minutes 27, 29, 11 minutes 30 seconds. And where is it? Directly below us. So now it's 40 seconds. 11 minutes 50 seconds. We're just above it. So time planning was quite good, happy about that. Also the heading worked out in the end. So you see, you don't have to be super precise in order to make it to your destination. So I did a bit too much of weaving left and right. Could have done much better with this. Speed was okay during most of the part. We saw this our arrival time. So yeah, we're here. Gravesend Air Traffic Control. This is Firefly orbiting above the airfield at 4,000 feet, requesting permission to land. Okay, let's set up for the landing. Power setting, RPM to almost maximum. I like to start with 30 inches of pressure. Give it already a bit of flaps to help in slowing it down. Let's up and down. Assume we received permission to land. Wind is coming from 122 degrees lower. So it's pretty much smack to the side, so we have crosswind conditions. It's a bit better if we land from the north to the south, so we have a bit of headwind as well. This is Firefly on overhead brake at 4,000 feet. Approaching for a landing from north. So back pressure, manifold pressure to landing, slow it down. I should be able to land here below 200 miles per hour is indicated. it's almost not so good, of course, but it's windy now. Still too fast. So now we'll make more and more like 2,000 feet. Down below 200. It's Firefly approaching final from north. Flaps fall down. I should like the second kind of taxi mode. Slow from 50 miles per hour. Still descending. Okay, approaching stall speed. I think I can make it without adding power. Slowly, gently braking, back on the power. Okay. Tail wheel unlocked. Okay, that was not too bad. Runway is clear. Gravesend air traffic control, Firefly requesting taxi position, parking position. Traffic control, Firefly. I heard hangar 1. Say again. Roger that. Hangar 1 it is. Now look at the wind indicator there. Wind is coming from the south. Okay, I should check my weather report better next time. So near the ground, the wind is coming almost from the south. Okay. Let's turn around here to enjoy the view. Brakes. Turn off the engine. Parking lights off. Gun side off. Increase power. Mixture back. Engine is dying. Fuel off. Magnetos off, battery off. Okay, that was it. A short navigation flight. I hope you were able to follow me through the planning process. I know it's tedious and you can make shortcuts there, of course. Yeah, but you lose precision on the way, both on speed, that is flight time, and also with the wind correction. Yeah, you need to have the correct speed and the heading, etc. So you see, it's not very easy to calculate this, but it's not witch work either. And of course you can simplify it, and you see you don't have to be super precise, especially if the flight is not that long. For myself, I have fun in the planning process, and then to see how it goes during the flight. And of course I find mistakes in my planning all the time, as you saw today, and it's always good to practice flying. Yeah, I hope you enjoyed it. If you have questions, just write in our Discord, or send me a message, or comment this video. Yeah, we would love to read about it. So wish you good luck on your own flights, for your planning and for the flying itself. So this is Firefly signing off. Bye bye.